Welcome to my channel. Today we are going to discuss about the performance analysis of an algorithm. So the performance of an algorithm can be analyzed by using two ways. One is time complexity and another one is space complexity. So time complexity is nothing but the amount of time of that an algorithm requires for its execution is called as a time complexity. So time means here the amount of time that of an algorithm it requires for execution of its task, that is called time complexity. So time complexity can be divided as three types. So first one is best case time complexity. So best case time complexity is nothing but if an algorithm requires minimum amount of time for its execution, then it is called as a best case time complexity. So observe here one example. So if you are taking linear search, so this is an array. So array contains 10, 20, 30, 40 and 50 elements. That is 1, 2, 3, 4, 5 elements are there. So here we want to search, for example, we want to search the element 10. First this key element will be searched with the first element. So then the element is match is found. So it requires only 1 unit of time. So that is it requires the 1 unit of time for searching. So this is minimum time for searching. So it will be treated as a best case time complexity of an algorithm. So next we'll discuss about the worst case time complexity. So worst case time complexity is nothing but if an algorithm requires a maximum amount of time for its execution, then it is called as a worst case time complexity. For example, if you are taking linear search, so assume that an array contains these 5 elements 10, 20, 30, 40, 50. So now I want to search the element 50. So first 50 will be taking and first element read from an array and compare with 50. So there is no match found. So next 20 will be taken from an array and compare with 50. So this is also no match is found. So next 30 will be read from an array and compare with the 50k element. So then the no match is found. So next 40 will also read from an array and it is also no match. So after that finally the 50 will be read from an array and compare with this key element. So then the match is found. So here the last position of the element of an array will be matched here. So here the maximum amount of time taken for searching of last element is 1, 2, 3, 4, 5 units of time. So it is a maximum time of searching. So it will be treated as a worst case time complexity of an array. So next we'll take another third type, average case time complexity. So if an algorithm requires average amount of time for its execution, then it is called as a average time complexity. So here assume that an array contains these 5 elements. So if you are searching second element, third element or fourth element, so then it will take average time for searching. For example, assume that we are searching the element for 30. So first it will read the first element of an array, that is 10. So compared with this one, so no match is found. Next read the 20 value from an array. So next no match is found. So next read 30 from an array. So then the match is found. So here it will take average amount of time, that is 3 units of a time for comparison. So it will be treated as a average case time complexity. So next we will go for the general rules for calculating or norms for calculating time complexity. So first one, rule 1. So rule 1, if you are taking loops, so they assume that this is a for loop. So here one statement is there inside a for loop. So this statement will executing n number of times within a loop. So that will be become as an time complexity of that an algorithm. So assume that observe here how we can calculate the time complexity for the loops by using rule 1. So first here I equal to 0, I less than n, I plus plus, s equal to s plus I. This is our code for loop. So here I less than n condition will be checked for n plus 1 times, n plus 1 number of times. For example, assume that n equal to 3. So first 0 will be assigned into I variable. So 0 will be compared with 3. So condition is true. 1 will be compared with 3. It is also true. And 2 will be compared with 3. It is also true. So after that the I value will be increased and 3 is also compared with 3. Condition is failed. So in this way, so totally the condition is tested for n number of 1 times. So next coming into this statement. So this statement executes n times. N times means it will execute 3 times. So totally, so our equation is so 2 n's are there, so 2n. So constant value is 1. So here in this case omit the constant values. So here omit the 2 and 1. So you need to take the n value n. So our time complexity for loop is O of n times. So this is regarding time complexity for loops. So next coming into nested loops. So nested loops time complexity is nothing but product of the statement of inside of the for loop and product of the outer loop statement. So this is regarding time complexity. So this is a nested loop and this is a outer loop. So observe here time complexity is for nested loops. So we are taking one example. So here in this case the outer loop will be worked, check the condition for n plus 1 times, and then the inside loop the condition is tested j less than or equal to tested n into means this for loop statement will be executed n times for execution, and this condition is checked for n plus 1 times. So totally n into n plus 1 times will be executed this statement. So totally our equation is n square plus n. So after that this statement, the inside statement will be executed so n number of times and n times will be repeated. So totally n square times. So totally our square equation is 2 to the power of n square. So 2 n squares are there. So this is 1 n square, this is another n square. So 2 n squares and 2 n's. 2 n's means this is 1 n and here another n is there. So 2 n and one constant value. So 1 is a one constant value. So here, so we are taking the exponent of the expression which is having highest value. So this is 2 to the power of n square has having a highest exponent. So in this case we are eliminating the 2. So just we are taking the n square. So totally time complexity of this nested loops are O of n square times. So next we will discuss about the consecutive statements of the time complexity. So maximum one of the loops which is executing for its time complexity, so that will be become as a consecutive time complexity. So if you are assume that if your program having multiple looping statements, so then which looping statement is taking a maximum time for execution of its an algorithm, so then it will be become as a time complexity of that algorithm. So assume that here 2 for loops are there. So this is one for loop. So this is one for loop. So this is another for loop. So here I equal to 0, I less than or equal to 10, I less than n. So this condition will be executed n plus 1 times, and this statement inside the for loop will be executed n times. Totally our equation is 2n plus 1. So here the time complexity of this for loop is O of n. So next to take nested for loop. So in nested for loop this outer loop will be check for condition n plus 1 times. So the inside loop j less than n will check for the condition n into n plus 1 time. The inside loop, the statement that is nested loop statement will be executed n into n times. So totally n square. So after that the time complexity of this total expression is calculated. So 2n square. 2n square means here 1n square is there. So here 1n square will be calculated. So 2n square plus 2n. 2n means here 1n will be coming after calculating. Here 1n is there. So 2n plus 1 constant. So after that here we are taking the exponent which is having high. So in this case 2n square having a highest exponent, so here omitting 2 and we are taking only n square. So total time complexity of this second nested loop is O of n square. So here two these consecutive statements having a time complexity, two time complexity. First one complexity is O of n, second nested for loop complexity is O of n square. So here this is having a highest time complexity, so this will be become as a time complexity of these consecutive statements. So like this manner. So next rule 4 is there. So if you are taking a if else statement, so if else statement, if our algorithm contains if else statement, so the time complexity become as an, so which is having a so highest maximum time complexity in two cases, that will be become as an time complexity of that an algorithm. So for example, assume that if condition having s1 and s2, so in this s1 and s2, which statements are having highest time complexity, that will be become as a time complexity of that algorithm. So I assume that here observe one example. So if n less than 0, so a condition return n value, and else so this else part related to entire this part is related to this else part. So here if statement will be calculated as a one unit of time, and return statement will be treated as a 1 unit of time. This else part will be treated as a 1 unit of time. So totally time complexity constant value is 3. So inside else part we have a for loop. So in this for loop the time complexity will be calculated here I less than n. The condition is tested n plus 1 times. So this statement will be executed this n number of times, and the return statement will be become as a 1 unit of a time. So totally 2n plus 5. So 2n plus 5 is a time complexity. So here we are taking the, so which is having a highest exponential value. So this is 2n. So here we are emitting the constant value 2. So O of n become the time complexity of this algorithm. So in this manner, so calculating the time complexity in if else statement. Okay, thank you. This is regarding time complexity of an algorithm. Next video we will discuss about the space complexity.